Good afternoon, everyone. This is Mr. Taylor. I want to talk to you about 13.2, the algebraic representation of dilations. We are still in Unit 5 going through Lesson 13. The learning objective for this particular lesson will be you will find points on a dilated image by multiplying the x coordinates and the y coordinates of the original figure by a certain number that we call a scale factor, which will create an enlargement. Again, please review the vocabularies that we presented earlier in this lesson, in lesson 13, so you can understand terms that will be used here. Graphing enlargements. When a dilation in the coordinate plane has an origin at the center of dilation, you can find points on the dilated image by multiplying the x and y coordinates of the original figure by the scale factor. For scale factor k, the algebraic representation of the dilation is xy as it goes to k times x comma k times y for an enlargement where k is greater than 1. That means that the scale factor is greater than 1. This is not anything to just be afraid of. I know you can remember back when we were talking about the algebraic part, we talked about k being a constant. So if we take a constant and multiply times x, let's just say that this constant is 7. So that's just saying that for x comma y in your coordinate plane, you take each particular point and you will multiply 7 times that x value and 7 times that y value. So that's exactly what this k means. Okay? So we have a figure that's to the right, and this figure is a pre-image. So we're saying that this is the original. And it says that the center of dilation is the origin. So this just means that, let me get my little pointer here. This just means that from here, see, is going here, is going to each particular vertex, to each particular vertex, to each particular vertex. So it means if you were to draw your whatever, since we're talking about enlargements, then it's going to be this origin, your origin will be the center of that particular vertex, no matter where it is. Okay? Let me just erase this and get this out of your way. Just wanted to show you what that meant. Now, the author says in this particular problem that he wants you to practice, he says that the figure is shown on the grid is the pre-image, and he tells us that our x and y, we have our x and y coordinates, that's 2 and 2. So if we went here over 2 and up, over 1, 2 and up 2, he's talking about this coordinate right here, and he said that's 2 and 2, and he says your k is 3. So what he did to get this is he took 2 times 3 for x and 2 times 3 to get y. I'll clean it up a little bit for you. So that's what he did to get the 6 here. So what you want to do is you want to look at the rest of the coordinates here, where your actual lines are meeting here. And start from there and list your vertices. So here, just to help you out, if I went over 1 and up 1, 2, I would have -1 and 2 for one vertices. If I went over 1, 2 and up 1, I'd have -2 and 1 for one vertices, and so forth. So go ahead and stop the video and see, can you work this, and then come back and uh, see how well you did with listing the coordinates. Okay, once you complete that, it asks us, what is the scale factor? Now, if we go back, we say the scale factor is the number that is being multiplied by your x and y coordinates to cause the enlargement. So here it says 3 is being multiplied by both x and multiplied by y. So you need to think to yourself, would 3 be the scale factor? Then C says, apply the dilation to the pre-image and write the coordinates. So that means do your math, and in the second column, go ahead and list the coordinates in this particular table, and you're going to do that here. And then once you finish with that part, then it says sketch the dilation on the coordinate grid. So go ahead and stop it. You take some good time here if you feel that you're still a little confused with what we're doing, then just come on back and we'll go through it. Then I need you to reflect, how does this dilation affect the length of the line segments? And this is something that you might want to look at, because I have seen test questions, dimensional change, and what the effect of a scale factor on a particular image. I've seen those questions on the test. And then, how does the dilation affect angle measures? Okay, so go ahead and stop and answer those two, and then come back and we'll work it together. Okay, so already pre-done. So remember what we did to get the first one is we did 3 times 2, so we multiplied both x and y times 3. So we're going to, here we had 2 and a -1. So we're going to multiply again times 3, times 3, times 3, times 3, times 3, times 3, times 3. So I'm looking at 3 times 2 is 6. 3 times a -1 is a -3. So that's going to give me my second image vertex. 3 times 1 is 3. 3 times a -1 is a -3. So here's another vertices. 3 times 1 is 3. 3 times a -2 is a -6. Remember the rules of integers, that a positive times a negative gives us a negative. So here, 3 times a -2, -6. 3 times a -2, -6. 3 times a -2, -6. 3 times 1, 3. 3 times a -1, -3. 3 times 3 is 3. 3 times a -1 is a -3. 3 times 2 is 6. So here is our original, and this is our image. And we can see that here. So these are the points that we plotted. Let's see, can we find them? We plotted, we went from 2, 2 to 6, 6. So 1, 2, 3, 4, 5, 6, up 6. Here's our new point. Then we went to 3, -3. We went over 1, 2, 3, down -3. That's our next point. Then we went over 3, 1, 2, 3, and we went down -6. 1, 2, 3, 4, 5. Here's our next point. Then we went to -6, so we went to the left, 1, 2, 3, 4, 5, 6, down a -6. Here's our next point. Then we went over 6 and up 3. Here's this point. Then we went -3, 1, 2, 3, up 3. Here's this particular point. And then we went, what do we have left? -3 and up 6. And here's this point. So this is our pre-image, and here's our image. And as you can see, if we were going to draw this line, as I was showing you a little bit earlier, if we were going to draw, see, this kind of comes straight through just like that. Okay, so you see it'll run from through one vertices to the other vertices. Now again, we know that the scale factor, we talked about that. We know that the scale factor here, since we are multiplying everything times 3, is going to be 3. And if we apply the dilation, which we did now, this is going to be our image. And now over here we have a processing skill question. This question goes and says, well, you want to sketch it, so we did that for D. But this question says, what effect would a dilation of 4 times x and 4 times y have on the radius of a circle? So that means if I'm just going to draw a circle and then I'm going to go 4 times that circle, not a nice circle, then your dilated circle will be the radius of your dilated circle. So because that's the radius there, this radius here will be 4 times this particular radius. So that's all that means there. You need to know that here in just a second when we look at the next part. So on your reflection, it says, how does the dilation affect the length of each segment? So it affects it by the actual scale factor. So the scale factor was 3 times. It affects it by 3 times. Then it says, how does the dilation affect angle measure? Well, they're similar figures. So listen, dilation does not change the angle measure. Make sure you understand that. All right.